This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Draft Lab knows that quality and consistency are your brewery's top priorities. Draft Lab provides easy-to-use sensory analysis tools designed to bring your tasting data into action. To start your free 2-week trial today, visit draftlab.com. That's DRAUGHT lab.com.
If you're reclaiming that yeast, or you want your profile to be the same this week as it is next week, you have to be very sensitive to the fact that you're dealing with something that's alive. And if you don't treat it right, it's not going to behave correctly.
This week on the show, one of the smartest brewmasters I know talks about keeping yeast happy. This episode originally aired in April of 2017. We'll be back next week with a brand new episode you won't want to miss. There's a whole bunch of stuff the two of us could talk about today, but I'd like to focus on an article that you wrote for the last Technical Quarterly of 2016. It's called Maintaining Good Yeast Health, a Reflection from Practice. This is a very good article, and you know me well enough to know that I'd tell you if I thought otherwise, right?
Right.
Yeah. So here's what I like about this article. For starters, it's got a decent dose of practical advice based on extensive experience regarding yeast storage times, pitch rates, water chemistry, and other stuff. And then you also cite, I think, about 10 great references that readers can leverage to go learn more about specific topics. And then the third thing is that it embodies a discussion you and I have had several times about education, the needs of today's craft brewers, and shortcuts versus real understanding. We can talk more about that later if you'd like. But I actually sent this article to someone just earlier today who wrote to me asking why their fermentations are now finishing higher than what was previously normal to them. And I especially wanted them to see your advice, which I'd also given previously, about knowing fermentability up to, in advance, up front. So Why don't you start off by telling listeners just how important and easy that is to do?
Well, it actually isn't an easy process to do. It's a forced fermentation, actually. In order to generate the value that you need, so you'd back calculate it from that process. So you need an exacting process, and the ASBC has that identified. It's on shaker tables, etc. Once you have the equipment and that ability set up, it becomes something that you learn to live with, and you look for those values ahead of time so that you can actually see if your brew house is performing properly, and from that you can also go back to whether or not you've got the right material coming in from your suppliers, if the suppliers actually have made some shortcuts, etc. So to me, having an RDF or fermentability level is premiumly important to just about anything that you're going to do as far as creating a beer and a beer style. Without having that, I think you're kind of lost in many respects.
Yeah, I think you're totally flying blind if you can't anticipate where a beer is going to finish in some regard. Let's talk about, you write about fan, and we often hear generalizations about fan. For example, you hear things like all malt brewers always have enough fan and never have to worry about it. Your article basically says, hold the phone, it's not quite that simple. Fans should be tied directly to the amount of yeast that you're trying to grow, and you also talk about the different categories of fan that produce different results. Why don't we talk about those concepts a little bit?
Sure. It can be a complex concept, or you can completely ignore it. It all depends upon what kind of a brewery you want to be. But if you look at free amino nitrogen and you look at yeast growth in general, you're looking at somewhere around a need for about 100, 120 to 140 parts per million of free amino nitrogen to grow a reasonable amount of yeast in your process. Now, if you look at what most craft brewers are doing today with an all malt process, you can end up with free amino nitrogen content as high as 400 ppm. Now, if you're only using 120 of that, that's a lot left over in your process, a lot for turbidity, a lot for trub, etc. There's a lot of opportunities with that, from mouthfeel and bacterial contamination. We can go on for a while, but let's push all that aside. If you're trying to influence the flavor profile that you're creating with the beer, you have to be very aware of the free amino nitrogen content. Because the yeast uptake the free amino nitrogen in categories, and it's 4 basic categories. Where you look at category 1 are amino acids that are primarily non-flavor generating when you look at how they make the transition in the process to higher alcohols, aldehydes, and esters. Category 2 amino acids tend to have the rose, the floral, the fruity, the banana flavor notes that are associated with those amino acids. Category 3, you get into other flavor notes, sulfury, and you can get into some fusols and solventy kind of notes. And then category 4 is just proline. So you kind of forget about category 4 for that matter. But if you have significant levels of free amino nitrogen, the yeast will uptake category 1 primarily right from the start, and will consume primarily category 1 amino acids. And then the flavor notes that are generated from that only come from those amino acids. And with that, you don't get a lot of fruitiness. You don't get a lot of depth in the solventy, aldehyde, or other flavor notes that you might be looking for in your beer. By dropping the free amino nitrogen content, and you do that by dilution, either using crystal malts or other malts that have completely glassified or eliminated the protein content, or by using adjuncts. Ooh, I said the adjunct word. That's a nasty word, apparently, in circles. But by diluting the protein content, you can actually boost beautiful ester profiles by influencing the category 2 amino acids to pop out. And you can even take it as further and really reduce your free amino nitrogen content and start focusing on category 3 amino acids and look for sulfur notes and solventy notes, and even the rose phenylethyl acetate tends to pop out in category 3. So there is a lot of complexity when you look at free amino nitrogen and the actual outcome of the flavor that you're looking for. If you're in the high end, in the 300, 400 range, all you're really going to get are the flavor notes that you add, the hop profile, and the grainy notes associated with it. So it's a matter of how much complexity you want to add to your beer flavor.
Very good. You briefly mentioned zinc additions. Why don't you tell us a little bit about your personal observations with zinc?
Zinc is interesting. It's a dynamic tool. Some folks just accept the amount of zinc, and you do have significant amounts of zinc in your grain. But if you're looking to influence settling of the yeast, the timing of settling of the yeast, the overall health of the yeast, there's a balance required for calcium and zinc levels, and it's highly yeast dependent. It'll also be tied directly to your water chemistry. So it's one of those things that you have to play with. But in my past life, we would actually make tiny adjustments to the zinc additions to actually force the yeast to actually fall out of suspension at exactly the right time. So you'd end up with an attenuation that fit exactly where you wanted it to be, which may be several points above your endpoint that you're looking for, so that you can carry over to a secondary fermentation if you're looking for that process, a small amount of sugar. But if you don't have the right mineral balance, you're not going to get the yeast to perform properly. At the same time, without having the right mineral balance, yeast is not healthy. You can have too much zinc, or you may not have enough. And getting robust and continuous performing yeast, it's very important to have a good balance. And one of the easiest markers to work with is zinc.
By the way, I went up to the District Western New York meeting in Utica in February, and Joe Kenny, who works there at FX Mat, gave a great presentation on the importance of zinc and how they've been able to manipulate flocculation, just as you were talking about with zinc additions to better control their process. And he talked a lot about some of the trial and error that, swings from, complete peanut butter to very powdery and everything in the middle. And so it was really interesting to hear that. And, interestingly enough, Mark, much like you've said about FAN, they're also trying to tie zinc back to how many yeast cells are we trying to grow number rather than a standard ppm spec.
Right.
It was a really great presentation. He talked a lot about how zinc content changes, as the yeast multiply. So it was a great presentation. I encourage listeners to look for that one in the district presentation archives over at MBAA.com. Coming up.
If we could analytically see a difference at 72 hours, and we actually start to taste a difference at 5 days, then you got to recognize that anything that you do that's outside the realm of cautious care with your yeast is going to have an impact.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas.
This Master Brewers Podcast is proudly sponsored by Barna Mechanical, a full-service design build firm specializing in turnkey process and utility systems for the brewing industry. We partner with some of the best craft brewers in the U.S. to ensure the great beer they brew is what their customers get in every glass, bottle, can, or keg. You know beer. We know breweries.
Additional support provided by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
A lot of districts just wrapped up their fall meetings. Here's what's on the Master Brewers calendar for the rest of the year. There's a HACCP course and a district meeting in Ontario, November 13th and 14th. Districts Milwaukee and St. Louis both meet November 15th. November wraps up with a webinar on strategies and tactics for being inclusive and building diversity in craft beer. The annual District St. Louis holiday party is December 7th. And it's not too early to start making plans for the 2019 Master Brewers Conference. If you can only make it to one conference in 2019, this should be it. We're really mixing things up this time and heading to the Calgary Convention Center to see how Alberta celebrates Halloween. I can't wait to see what decorations Tressa comes up with. Check out the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show.
In my past life, too, we never looked at peak yeast cells because of the dynamic differences between the fermenters from brewery to brewery. We always looked at fan uptake and controlled our yeast cell growth based upon the amount of fan that was actually taken up by the yeast cells, which correlated directly to a peak yeast cell count that you could actually tag to a specific brewery. But you actually had to have the swiggles in the right locations, your sampling points at the right locations, because you get false readings in some respects. So it's when you compare a brewery of with 4,000 barrel fermenters with 2,000 barrel or 1,000 barrel fermenter, the actual peak yeast cell counts don't necessarily correlate based upon where the swiggle is located. So you needed to find a more dynamic number, which was actual uptake of the protein, and that correlates directly to yeast cell growth.
That makes sense. Mark, you mentioned wort aeration. I think most craft brewers are using flow meters to standardize their oxygen input into their process, but I'm sure many of them aren't considering some of the other variables you wrote about, such as liquid fill height on fermenters, transfer delays, things of that nature. What advice do you have on this topic for the craft brewer who's in search of more consistency in their fermentations?
Wow. If it's a single fill process, so you got one brew, one transfer to one tank, it's fairly simple, except when you may be transferring across a cellar, or in some case a warehouse that has a string of fermenters where you have the air injection on one end and maybe the last tank at the far end of the warehouse is going to have a little different amount of oxygen going, or air going into it, even though your rotometer or your metering process says you're getting the same amount in, you're actually going to get more absorbed with the greater amount of line pressure, etc. The reason why I talked about transfer delays and fill heights, etc., is on multi-fermenter brews, or multi-brew fermenters. Multi-brew fermenters. It gets a little more complex. In the brewery that I was working in, where we started looking at back pressure specifically, we actually had 4 header systems. The air injection was by header number 1, and we had I think it was 8 fermenters, 8 4,000 barrel fermenters on each header. So you can consider the distance was significant. But what we saw, which is even more significant than the distance from header 1 to header 4, was actually from tank 1 to tank 4 in that line, where when you were filling on tank 4, you ended up with much higher yeast growth because you apparently were getting more air into it, etc. So we ended up putting back pressure valves on the lines to actually hold a constant back pressure to the liquid height and the back pressure that would be seen at the farthest tank in the system, so that any tank receiving the beer flow or the wort flow and the oxygen level or oxygen injection was getting exactly the same amount of absorption based upon that back pressure. So it was very dynamic in trying to work out that particular process. But when you look at the consistency levels, you're going to find that there are 2 schools of thought around multi-fill fermenters, multi-brew fermenters, and some folks will tell you that you actually have to have a consistent flow of oxygen going into the wort, along with the wort being consistently flowing all the way through to the fill. Some authors will also tell you, no, you don't have to worry about that. You can fill and then stop and fill and then stop and then fill and then stop. I always look at these things as if I'm the yeast cell and I've got my little backpack of oxygen and I'm trying to get myself into a fermentation mode, and along comes a brew and I get all this nutrients and I feel really well and I get my oxygen supply and I'm doing wonderful, and then I start my fermentation. I start moving into my lag phase, etc., and start to change my biological processes, etc., in order to fit an anaerobic process. Now, technically, I never really entered an aerobic process, but that gets pretty deep, so we'll just leave that alone, other than the fact that my processes are now swinging more towards a strictly anaerobic process. And then all of a sudden, here comes another brew and more oxygen and another rousing process, etc. And if you can think about that from 1 or 2 brews, probably not a big deal. But when you're looking at 6 or 7 or 8 brews, and this gets into the concerns, and one of the reasons why I wrote this paper was primarily around thinking about breweries that are growing, the ones that have gone from the small single brew fermenters to the multi-brew fermenters, etc., gone from one side of the country to the other side of the country, trying to make their beer consistent, etc. The processes have to be lined out in such a manner that you're almost anal about being consistent in the processes in order to make sure that your yeast performs exactly the same if you're trying to make the same beer in each location. Sometimes you end up with breakages, or something goes wrong in the brew house, or something happens where you don't have a process ready, and you find yourself in a situation where you've got a delay. So it magnifies that concern even farther from the standpoint of I've got myself in my fermentation and I'm making myself go into this anaerobic process, and along comes another brew with more air, etc. Think about that now that you've You've delayed that an additional 2 hours or additional 4 hours or half a day. What are you actually doing to that yeast cell as far as taking it in and out of a process? And today you do it one way, and tomorrow you do it another way. Sometimes it's going to work, sometimes it's not. But I'll tell you, in each and every case that you vary it, you have a variable as far as the flavor that you're creating in those processes. So I started my career with a large brewer, and I did literally hundreds of specials on these processes. Adjustments for free amino nitrogen, adjustments for zinc, adjustments for temperature, pitching rates, oxygen, delays, three-day holds of yeast in a yeast spring, 5-day hold, 7-day hold, 10-day holds, high temperature, low temperatures, etc. And all of these things were all put together and mapped through the processes, and it goes back to the authors, the Graham Stewarts of the world, the McCaig's of the world, etc. Those guys were the basis of much of the 1960s through 1990s research on yeast. And what we did was we mimicked a lot of what was actually taking place in these research articles, and trying to prove it to ourselves what made the best sense, etc. So when you get into an anal process of trying to make sure that brewery A and brewery X are the same process from a flavor standpoint, you have to have a very high level of exacting control. Oxygen is just one of those points. And I'll take that one step further. And I didn't talk about this in this article, and that's the type of micronization of the bubbles. The brewery I work for made a huge leap in its process control by changing from a single stone inline to an E-cell Huber process for air injection. I don't need to sell an E-cell Hubers to you, but the technology of exploding the air under the pressure transition across the E-cell Huber unit and micronizing the bubbles gave us such a significant level of control on the amount of air that we're actually adding to the beer or the wort at that time, to give us a level of control to plus or minus 2 to 3 million cells in our peak, or within a couple parts per million of free nitrogen uptake. So just to give you an idea that if you use the wrong stone, you use the wrong process, or delay in the process, or have inconsistent pressures in those lines, you're not going to get the same amount of air, you're not going to get the same amount of fermentations.
That's great, yeah. Or if your stone clogs up over time because it's not being cleaned properly, things like that. And I think this stuff is totally relevant to today's craft brewer, because even if they're not trying to flavor match across multiple breweries, pretty much everybody is working with multi-fill fermenters, even if they're very small. So it's something that I think affects almost everybody. Right. Very cool. Well, early in the article, you wrote about something that is unfortunately still far too common in some of the younger, small breweries. You wrote, "Today we find that brewers will hold yeast often for days in the cones of fermenters and then question the degraded performance of the yeast." Later on, referring to flocculation, you write, "Once this separation process begins, so should the timer. Your objective should be to get yeast cooled as quickly as possible to a temperature that approaches 34 Fahrenheit with minimal agitation and exposure to oxygen." This is fundamental stuff here, Mark, but how about explaining what is likely to go wrong if folks dilly-dally with yeast cooling and harvest?
Well, it becomes a self-digestion process. Yeast doesn't like to be exposed to warm temperatures. It's like you dropping into a pool and holding your breath. I mean, seriously. If the yeast is not getting nutrients or it's not getting oxygen, etc., and not carrying on a normal life cycle, it's going to shut down. And it may shut down partially, or it may shut down all the way. And as it shuts down, it releases its enzymes, and it becomes a self-autolysis process where the yeast become digesting the yeast cells next door to it. So you only killed 10 million. Well, you've damaged probably 50% of the crop that's there, and it's not going to perform exactly the same way. It may delay in its process for growth. You may pitch the same amount and then actually not get the same amount of growth. So your ester profiles are all screwed up. Your flavor profiles are all screwed up. Your alcohol levels and the amount of fermentability that you're getting out of that yeast may not reach the attenuation levels that you need, et cetera. So it's your yeast is a living organism. And I think people forget that fact, that it's sensitive. It's not something that you can forget about. It's extremely sensitive to the environment you place it in. I read about people saying, well, why don't I just add some more wort and oxygenate it and stuff like that? Well, yeah, okay, but it's not a consistent process. What are you trying to get out of your process? If you're just trying to make a healthy yeast or trying to get to a one-shot deal with a particular type of yeast, then have at it. Do whatever works for you in some respects. But if you're reclaiming that yeast, or you want your profile to be the same this week as it is next week, you have to be very sensitive to the fact that you're dealing with something that's alive. And if you don't treat it right, it's not going to behave correctly. I tell you that the brewery I work for, 72 hours. 72 hours from the time the cooling was turned on in that fermenter, that yeast had to be back in a fermenter. If it was not in the fermenter in 72 hours, we threw it away. And we proved to ourselves that even at 72 hours, you were starting to stretch the envelope of minor flavor changes. 5 days, it was obvious to taste panel members with their nearly every taste panel member. 7 days, forget it. It started to be evident to consumers, etc. So if we could analytically see a difference at 72 hours, and we actually start to taste a difference at 5 days, significant taste differences at 5 days, then you got to recognize that anything that you do that's outside the realm of cautious care with your yeast is going to have an impact.
Yeah, and you're talking 72 hours in an optimal storage condition too, right?
Yes. Yep.
Yeah. So think about how many folks are kind of working with suboptimal storage conditions and pushing it weeks or days, weeks, whatever.
Yeah, you're talking about cooling on, comb cooling, pulling directly out as soon as you get to a point where you have the right amount of yeast in suspension, pulling it right into brinks that have the proper agitation, and cooling, all automated temperature drops. Within hours, you're down to 34 degrees and you're under control. Agitator goes off automatically, the whole 9 yards. So you're absolutely correct. I worked in a brewery at one time where we did a Christmas shutdown, and we actually would hold fermenters yeast on them with a little beer on them and wait about a week to 10 days, and then we'd start harvesting this beer and start the process back up. And we fought those fermenters for weeks until we got to a point where they were back in line. So you end up with this period of time, a month's worth of releases that taste differently than the other 11 months out of the year. At one time, the brewery I used to work with, we used to have a holiday schedule. We put the same process together, but we actually remapped that whole process to a maximum of a 72-hour shutdown, and that was the holiday window. And you would actually, once that beer dropped off and moved to the next stage of fermentation, we were back into the pitching process. Now, so we actually had to grow the yeast up. So our 72-hour window was our holiday window. There was no week or 10-day type process, simply because we could never make it work from a flavor standpoint.
Yeast does not take vacations.
No, it doesn't. That's
That interview with Mark was recorded in the spring of 2017. If you want to read Mark's TQ article, you can find a link in the show notes or by typing yeast health into the industry's best search bar at MBAA.com. And if you want to dive deeper into zinc, check out episode 41 with Joe Kinney. Hey, remember the Belgian beer book that Sten Mertens and Jan Stencils talked about on episode 101, The Yeasts of Tomorrow? Well, great news. It's now available in the Master Brewers bookstore. Just go to mbaa.com/store and type Belgian beer into the search bar to get your copy today.
Calm down, I'm moving too fast.